Okay, everybody, so in the last video, we talked about this problem, and I got an error message when I put it in the calculator, so I must have hit a button wrong, but I was about to run out of time for my video because I'm just using my phone, and my phone's not a great phone. But here it is. So I did an open parenthesis and a 1.0, and then for the E, I hit second comma, because you could probably see it better on your calculator, but there's an EE there. Can we focus on that? Yeah, EE, which is for the scientific notation. And then I hit the negative down here for the negative 14, and then a closed parenthesis and divide, and then I did the same thing for the negative 2, and then I hit enter, and I got 1 times 10 to the negative 12. And then I hit the negative button down here at the bottom again. And then the log, maybe I should just point with my fingers. And then in order to get answer, which is this answer, I hit second and then this negative button. Because if you look just above the second, it says ANS for answer. And so that will let you have the answer that it'll use the answer that you just previously calculated, and you don't have to worry about mistyping. And so we got a pH of 12. All right, so now it's time for part B. Calculate the pH corresponding to this concentration of sodium hydroxide. So you know what, this is the same thing. I probably didn't even need to do a video, but let's do it for practice. 8.4B. And this time our concentration was -6. So 1.0 times 10 to the -6 molarity. And it's of sodium hydroxide still. Let me double check that. Yes, sodium hydroxide. And so essentially this molarity, or this concentration, is equal to the hydroxide ion concentration. So in order, I'm going to skip a step here since this is the same kind of problem as before. In order to get the hydronium ion concentration, I am going to put the Kw, which is 1.0 times 10 to the -14, and then divide it by the OH, which is 1.0 times 10 to the -6. I probably should have done an extra step. I'm going to say Kw right here, and then I'm going to say OH right here. So that's what those are. And then when I do the math on that, entering it into the calculator the same way as before, sorry, I just had to think about something for a second. You don't have to put the brackets whenever you've got the actual numbers in, and I've been doing that because I forgot. So sorry about that. So whenever you divide those two, you get 1.0 times 10 to the, let's see, -8 molarity is your hydronium ion concentration. So then it's just the pH of negative log of hydronium ion concentration, which is 1.0 times 10 to the -8. And so you put it into the calculator the same way as I just showed you, so I'm not going to show it again. We can move on to another problem. All right. Don't forget that you can slow down these videos by going to, I think it's the lower right-hand corner, to settings and adjusting the playback speed.